Awesome. So, welcome everyone on the Puffer boosted technical walkthrough. I'm happy to host Cheyenne A and Cheyenne B here from Puffer on this call. For those who don't know me, I'm Adrian Hetman. I'm the head of the triaging team. You all know Mackenzie, but please, Cheyenne A, please introduce yourself.
Yeah, so I'm Shayan A. I work at Puffer. I got hired initially to do smart contract stuff, and then also been doing protocol design.
Amazing. And Cheyenne B.
Hey everyone, I'm Shayan. I've been working on more information security and code auditing before. So I joined 3 weeks ago as head of security for Puffer.
Okay, great. Thank you. Mackenzie, would you mind mentioning all the great details of the Puffer boost at very high level? How the
Sure.
rewards are looking, what people can expect?
So the information a little got updated just yesterday, where the scope got a little bigger than it was before. And these contracts are all deployed. There's about 800 lines of scope, lines of code. You can check that on the Puffer page. The rewards, we're going to have kind of a classic contest audit style where there will be a $50,000 prize pool. But on top of that, to help protect Puffer's 1 billion TVL that grew insanely, I think, over just the last 2 or so weeks, we have $200,000 per critical reward, 50,000 per high, 2,000 per medium, and 1,000 per low. And the way this will work for duplicates here is that they will get rewarded for the 50K pool. It's just going to be a common even split among people who find it, with regular Sybil resistance. So uniques will be rewarded a bit more. And then for the flat, crit high, those rewards, it's going to be an 80-20 split where the chief finder is going to get the 80%. And this isn't just the person who submits it first. This is the person who shows the highest severity of it first. So if you find a bug that's high, but then someone else shows out how it's actually critical, then the 80% would go to them instead. So it's not just about speed, it's also about thoroughness. That said, if you've shown how it's critical and someone can show how it's critical but steal $1 more, that doesn't change anything. It's just about proving the severity. So that's kind of the high level of the scope and the rewards. It's going to last for 2 weeks. Throughout this, Cheyenne, and perhaps some other members from the team will be available in the Discord chat to answer questions, hang out, just fill you in on any confusions regarding the code and otherwise. And then also they're going to be responding, Puffer team in general, very fast throughout the event to get those bug reports resolved. So 24 hours is our response time during weekdays that we're setting for. So in this case, I do recommend submitting bugs reports faster, sooner, getting that good feedback, getting back into the fray. And that is the overview of it.
Thank you very much. Okay, so let's start with our first question. Cheyenne A, I believe you will be presenting. So could you do a walkthrough of the Puffer code base, the one that will be in scope, and walk us through the logic there, because our community is mostly interested in those parts that you especially find mostly dangerous and critical to your security. From that
we can
code perspective. Yeah,
we can definitely do that. We had a plan to do like to just explain what Puffer is, and then kind of go over like the overview of what our protocol is before we dive into the code.
amazing.
Would you prefer that? We had the other Shine was gonna do that, and then I will do the code, go through in the deep code and everything after that.
Yeah, so Shayan B, if you could do a bird's eye overview of Puffer, what's the protocol all about, and what the new code base is also all about, and how that connects to the Puffer in general.
For sure. So just want to make sure you guys see my screen. It's like, yes. All right.
Yeah.
Thanks everyone for being here. We already started the boost, so we already get to make a lot of emails and issues there. So glad to see all these issues coming in. So for Puffer, like basically like a one-liner is Puffer is decentralized native liquid restaking protocol built on eigenlayer. This is like pretty loaded. Like there's a lot going on in this sentence. And a lot of these are not necessarily needed to be known for this specific boost. The main goal is like for Puffer to be a permissionless native restaking using eigenlayer. You have like Ethereum ethos to have like permissionless decentralization and try to make sure everyone can run a validator and participate in basically like this ecosystem. So I'm not going to go that much into detail here, but I really encourage everyone to read, because especially one thing we have in mind for the Immunefi is to continuously having these audits in the future when we deploy more. So just around that,
One
like,
moment, Cheyenne, before we go a bit further, some people said it's still loading for them. I am actually going to drop you a Google Meets chat on in our Telegram real quick, so you can join there. I'm going to make you a host, and you can screen share there as well. And so if the screen share doesn't work for people here, that link is going to be publicly accessible for everyone there as well.
they just share from there. Is that easier?
Well, share from both if possible.
You can just like open that one first.
I think sharing from both might lag it more, right?
Oh, that's a good point.
Cheyenne, do you want me to share the docs and you could explain, perhaps? If that works for you.
That works too. It's a bit tricky. But okay, yeah, let's do that. Like I'll send you the links on the chat and then you can share them.
Yeah. Let's do that. All right. Okay, here, let me share. And then, yeah, just tell me what to show. Here we go. Okay. Yeah. So we're here.
Yeah, all good.
All good for me too.
All right. Yeah. So the nitro is really good then. So yeah, this chart is like really complicated, but the main part that is related to this audit is like boost is I think the left up part is like the staker and the PufferVault. That's the main part that is in scope here. The rest are about like how the Puffer protocol functions. A lot of them are under development, and we'll basically update the scope as we go. So that was mainly it in this page. And Shani, I posted another link on Telegram if you can open that one up. Also, would be good.
Yep. It's big diagram loading. Yeah, there we go.
Drum rolls.
Right. Okay. This one?
Yeah, that's great. So maybe if we can make it, yeah, that's perfect. So there are like different phases that we're going through. So the first one is like pre-mainnet. And one of the main reasons that we basically started that is because Eigenlayer had an uncapped week, so everyone could deposit. And we wanted to be true to our users, early users. So Puffer started this whole pre-mainnet marketing campaign, like basically build a PDL and also help our users to gather Eigenlayer points while being early users of Puffer. So we just wanted to avoid having like puppy holders to be able to, so later on we have validator tickets and everything. I'm not going to get really into that. But this is like why we started this way. So basically like the first chart on top is one of the main functionalities that anyone could come in, deposit SDE, and get puppy. And that was the main functionality of the contract. So some of you already like reported issues about swap. So we have like swap functions, but those are already paused and they will be removed in the future. So initially we want to accept any token that the swap would like swap to like SDE and then deposit. But those are all paused. And in this chart, you can see they're like crossed. And that's the main part that has been done. So there is the second chart, the second box is about the Eigenlayer deposit, which we did basically on the week that Eigenlayer was open. And the idea basically was like the multisig, the operator multisig would send the deposit to eigenlayer call to PufferVault, and we would deposit it to the STE strategy. And that's done. We deposit most of the funds for that week. And that's where the contract state is. And in the future, this is the code also that is part of the this boost, is where the code can withdraw from eigenlayer, withdraw from Lido, and deposit to eigenlayer again. And so reading the ether and like deposit to eigenlayer again. And these parts are the parts that, especially on the eigenlayer side, is like really under development on the eigenlayer side, on our side. But this part still falls into the boost scope. Just want to pause here to see if anyone has any questions regarding the specific, or if Shayan, you want to add anything on this end.
I would quickly want to clarify that I talked to Ben actually, the pause is like queued. It's not gonna actually pause for like a day or two, but we're considering it as the swaps are paused. So we like are in the process of pausing the swaps. We just have a mechanism to basically have a delay where we can change anything. So we'll consider it as being paused, but it's gonna pause in like a day or two.
Yeah, and that makes sense. And thanks for clarifying that. The one question is that is this chart available somewhere for anybody to see and study?
We can send it on the channel, PufferBoost channel.
Okay,
Yeah,
awesome.
we'll do that.
And does anybody from the audience have any questions so far? Okay, 2 people are typing. Let's wait a minute.
And while trying to have the screen, if you go a bit down, so there is like these other parts of the chart that I put the box on as like under development. So I see some people that talked about, actually the underlying chart is not fully updated, but talked about how like Lido slashing would impact like the withdrawal and others. So we have some of the code there. I'm really interested that reading these reports, because some of them we haven't really thought about them. But just take them with a grain of salt if you see something there, but we can go back and forth on any reported issue to discuss.
Okay. One question is, the repeated question is, if you could explain that no op module that was in the previous chart.
Oh, node operator, I think. So they're talking about this. So, yeah, basically the node operator is just the person who operates a bunch of validators, and so this is just showing that they put up a bond, and they put up this is getting like too out of scope, but basically they have these validator tickets that you have one for each day that you can run your validator, and that's basically who that's talking about. So then they earn proof of stake rewards and restaking rewards from running AVSs. So that's like the core of our protocol. It lets you get with a 1 ETH bond, you can run a validator and earn more than consensus rewards.
Okay. Another question was regarding time logs. If you could explain how those time logs contract work, how they're integrated within the system.
Yeah, I was gonna go more in depth about the time lock, but and there is a document that I'll show you guys in a second. But
okay, so maybe we can leave that when we'll go to that part,
sure.
And we can just continue. I will keep that question in mind.
Perfect.
And just to clarify, the no-op and everything else that Shayan mentioned are not yet in the scope at this point. But
Yeah, pretty much we just have the PufferVault in this diagram. That's in scope. But yeah, feel free to look at our docs and see what we're building in the future.
There is one question. The boost page says PufferDepositor swap function are in scope, but due to them being paused, bugs will only be considered if they can bypass the pause mechanism. And the question is, would any mistakes in the correctness of these functions be considered?
Well, I'm with that statement, I'm trying to say that if you can bypass the time lock, then yes. basically, because then that implies that you have bypassed the time lock and you are able to call those functions. So in that case, if you find a bug with those functions, given you found a bug to get past the time lock, then yeah, that's all fair game.
Okay, thank
Also,
you.
to add something there, we added like 3 audit reports to our repo, and some of the issues that were reported already were those in the audit report. So please take a look there before submitting duplicates.
Yep.
Yeah,
Yeah,
and that's a really good point. When you find something, please look at the previous audits just to see if something was already acknowledged that Puffer may actually know about. Because otherwise, issue like that would be closed as a known issue. Okay, I think we can move forward. Please continue if you still want to present the overview of the Puffer, unless you are ready to go into the code.
Yeah. What do you think, Cheyenne? Should we do more stuff here, or?
No, I think I just wanted to give an overall view of like what we're talking about and then jump in the code. So I think at this point, and you're planning to show that demystifying access control link to, right?
Yeah.
All right. Yeah, go take it from here.
Okay. Honestly, I kind of want to do that first now. So here, let me quickly find it right here. So I'll go ahead and do that time lock because now it's going to be relevant. So we have this document that I think should be shared with you guys. Or if not, we'll post it in the chat. But this is our access control mechanism, so you can read about all of this. And so pretty much we have 3 multisigs, and so one of them here we have the operation community, and there's one we call pauser. So basically, the operation one is delayed by 7 days. It basically, I'll show you in the code, but it queues up a transaction, and then you, after 7 days, can execute it. The other one, the community one, can execute things without a delay. And then there also is a pauser, which I'll get to. And yeah, so they both can upgrade. So you can read about all this stuff, but here, we'll get into the code and it'll be more clear. Okay, so...
One thing here I just want to add, or do you want to talk about the operation versus community wallet? Because I saw some of the issues regarding that.
Yeah.
So the main thing I want to say here is like the operation is basically the Puffer team operating. It has like 7 days minimum delay. But the idea is like community safe wallet, which it says like there is no delay, is like in case community wants to take over the decision of the operators, they can. So there's no delay on that end. I saw 1 or 2 issues that we're talking about this, so I want to clarify now.
Yeah, good clarification. Yeah.
I have a question regarding that table. If you could scroll up.
Yeah.
Because it showed that time to execution on Timelock is no. And that doesn't mean that anything that goes through Timelock is sent immediately to Operation Safe Wallet.
This is saying that the time lock contract itself owns the the access control mechanism, like Open Zeppelin's access manager. So it's saying that contract can execute anything.
Okay, makes sense.
Yeah, like it has the default admin role. And then I wanted to clarify, like there was this point too about how the operations multisig itself is able to move assets to eigenlayer and like request the withdrawal from eigenlayer. So that's just like normal functioning of our protocol. So those ones don't have delay. But yeah, the other stuff has delay. And then this table doesn't include it, but I just saw that this one that has it right here. So this is the multisig that is able to pause the contract. I can't do anything else. Yep. Okay. So with that, if there's no questions with that, I'll dive into the code, and we'll look at the time lock contract as well. But I was gonna start with the vault. So basically, here I'll skip these imports, and we basically just have like all these variables that store a addresses important stuff like eigenlayers, strategy contract, strategy manager, the Steth contract, Lido withdrawal queue. So we deployed this contract and we assigned all these things. And this vault contract also defines our main token, which is PufETH. So basically the idea of it is that when you deposit ETH, you deposit Steth, you get PufETH in return. This right here, this receive function is performing this mechanism that we'll see where if we are doing a Lido withdrawal, we decrement an internal storage variable. And the purpose of that is we keep track of all our funds, so all of our Steth. And when it is locked up in a withdrawal, we account for that with this variable. And so this is decrementing it when we receive it back. We'll explain that a little bit more. And so this inherits from ERC 4626. So the deposits do that. And then the override here is just to make this pausable, as you saw from the Timelock. Same thing with Mint. Then I want to talk about this one. The withdrawal process for both Lido and eigenlayer is two-step. So if I skip down to, there should be a Q withdrawal from Lido. This one. So this one would go first. So we initiate the withdrawal to queue it up, basically. And then you call that function earlier, which I'll come back to. So going through this one, this is restricted to basically just operations or community. So we get the storage, we figure out the amounts, we increment this locked amount because we're about to queue the withdrawal, and we expect to get this back in the receive function. Then we agree the withdrawal queue can take our Steth. We request the withdrawal of the Steth. We keep track of the request ID for however many withdrawals there are, and emit some events. So that basically takes our Steth, puts it into the Lido queue, and queues it up for withdrawal. And then we come back to claim that withdrawal after it's ready to be processed. We have this mechanism here where we say that it is going to be a Lido withdrawal. Since it's going to be atomic, we are going to hit that receive function as I'll point out. So we go through, we see that we match all our request IDs that we have, and that needs to go through, and then we will basically make sure all the IDs we got are correct, and we actually claim the withdrawal. So when we claim the withdrawal, ETH is actually going to be hitting our contract, and that is what invokes this receive function. So since we just set this is Lido withdrawal to true, this expected locked ETH will be decremented. So yeah, so that happens there, and then we set this back to false. So you see that true, false. So I'll point out here that there was a bug that we had with not checking these request IDs, where someone could submit their own Lido withdrawal, and it would come back to our vault, but it would be a donation. I'm gonna explain it later. I feel like I might confuse people jumping into that too quickly, but basically that's a mechanism around that bug that you'll see, and I'll touch on more in detail later. So I covered Lido. So then we have redeem and withdrawal right now are not allowed. So this is the first phase basically of our deployment, our product offering, and we are basically this is kind of a marketing campaign to get people to just let them earn points on eigenlayer for now, and later on these two this contract will be upgraded to our PufferVault mainnet, which you can see on our GitHub, but currently not in scope for the audit, but then that's when the withdrawals can happen. This is an overwriting of the total assets function for the ERC 4626, and basically it is going to keep track of not only the current stETH balance of this contract, but also whatever is in EigenLayer or Lido, and then potentially an ETH, like if anything from Lido has been withdrawn. So that's there. Then these are basically like view functions for what's in EigenLayer. So it just figures out what is locked in EigenLayer from this contract and figures out if there's anything that is basically pending to withdrawal and adds those up. And similarly for Lido does the same thing. So anything that's locked up, which should match our accounting that we do on this smart contract to get anything that's pending from Lido. That's what's going on with this one. And then we have the deposit to EigenLayer function. So this is what is basically going on right now, where people deposit its stETH, and then the stETH is being deposited into EigenLayer's stETH strategy contract. So this function basically takes the amount and then increases allowance from this contract to EigenLayer Strategy Manager contract, and just calls their own deposit function to take the stETH from this contract and put it in there. And then again, we have this two-step process I mentioned for EigenLayer, like similar to the one I showed you for Lido. So we initiate the withdrawal. We are only targeting the EigenLayer stETH strategy contract. We figure out how many shares to withdraw, and we queue up the withdrawal on EigenLayer Strategy Manager contract, and keep an internal variable for this withdrawal route that we generated right here as a return value from this function call. And after some time, similarly, we'll claim the withdrawal from EigenLayer. So we get the withdrawal route. It has to match what we had. And we decrement the shares that we expect and then call this function to complete the withdrawal on the EigenLayer Strategy Manager. I showed you this one already. And this is just a function required by the ERC 721 standard. This is decimals for our token, so just like a ERC, basically ERC 20 thing, but ERC 4626 thing, because it extends ERC 20. And this is to authorize the upgrade. That's it. That was a little bit, so I'll take questions there.
We have one question, not exactly regarding the code. We'll go back to the code in a second, but Perseverance asks, the buffer boost says that Puffer Finance adheres to the primacy of impact for all impacts. So, if someone reports back for an asset not in scope, for example, Timelock, Vault, Depositor, will it be considered valid for this boost?
I think our answer to that was no, it was only the stuff that we mentioned explicitly to be in scope is what we were considering.
No, I just want to clarify that because like the Timelock, Vault, and Depositor are all the deployed contracts. They are part of this boost. Like everything that is deployed is part of it. Right? Like okay. So those are part of the scope. Everything else we try to like be as detailed as we can on the description. So things like swap or some other functionality like multi-sigs explicitly said that they are maybe detailed explanation of like if they're in scope or not.
Okay, thank you.
So to just make it super simple for everyone listening, if they find a bug that has an impact on the deployed contracts, it will be valid.
Right.
Great, thank you. I don't think we got more questions on the code, so if you want to just continue leading us on.
Okay, cool. Well, the pace is good. I'm soliciting comments on the pace. If you guys want me to go quicker or slower, let me know. I'm not looking at the chat, but Hopefully, one of my colleagues will tell me.
This is really okay. Keep
Good
the
pace?
pace.
Okay,
Yeah.
cool. So yeah, I wanted to show this one. So this is just the storage that was referenced earlier, right? All the different variables that we have. We've got them over here, and we have the location of our storage. So I think this was basically like pre-computed to figure out where that would be, and yeah. So this function returns basically, or like puts all these variables that are used in scope of where they're used in this previous code file I showed you guys. So that's it there. Then let's go to Timelock, I guess, the one that we talked about. So okay, so Timelock, we have all these errors and events that we define, and all like different variables. So the multisigs we talked about, the access manager. We have this minimum delay of 2 days, so we could change, in theory, like for the 7 days to something up to, or like not smaller than 2 days. And we have the pauser multisig we talked about too. And then this is the transaction queue, that basically the mechanism, right, for the operations multisig is to queue up transactions and before they're able to execute after a delay. So the constructor sets all these important multisig variables, the delay and access manager address. So those all get set. Oh, we have this function too. This one basically, I'll jump to it right now. It just makes sure that everything is not address 0. So just does some validation on those addresses there. So coming back. So the idea is to queue up a transaction, and it has to be done by the operations multisig. And we basically generate this transaction hash. We figure out when the transaction is able to be executed, so the current time plus the delay. And we queue that up. This is saying like if it already exists, that's not good. So, or like it's already been done. So we specify like in the mapping that transaction hash is locked until this calculated time. And we emit some events and the hash, and return the hash, sorry. Okay, so then pause. So it needs to be from the pauser multisig, and we basically, and this pauses everything. So, or sorry, the community multisig, I believe, can only can't call this function, but that calls it through a different method. But this one, this one you can specify the targets to pause. Yeah, I just misspoke there. So yeah, so you specify the targets to pause. Okay, this function is if we've already queued up a transaction that's like in the queue, basically, like, or waiting to be executed. We can cancel that and basically remove that transaction hash from our queue, from our mapping. So we're resetting that and emitting an event. So that's from operations multisig. And so yeah, so then this function is what actually executes stuff. So this is the one that's saying community multisig can do things directly. And then operations multisig needs to go through this flow to make sure that the locked until is like after the current time. And after executing that, we reset this this mapping, so another transaction hash can be added to that, and it executes and emits an event and returns success and data. So So I want to just clarify too, right? So like the flow is that you check the community multisig, it executes directly, but if it is the operations multisig, it goes through this flow, and then if it's anything else, it will revert unauthorized.
I have a question. Can community multisig pause any transaction from other multisigs?
From
Can it-
other multisigs. I that's a good question. Well, I think when the Timelock contract itself doesn't get paused, it or at least from my understanding, it like this contract itself doesn't get paused. It's just that the PufferVault and that basically the PufferVault just gets paused. So the community multisig could still queue up a transaction to unpause. Or sorry, the operations multisig could queue up a transaction to unpause.
Okay. And I understand the same is for the canceling transactions.
Yes. Yeah. So this contract itself doesn't get paused. It's just that the Puffer
Yeah.
Vault gets paused, yeah.
And basically, community vote can outvote other multisigs. There's no.
There's no delay.
Yeah. Okay.
Yeah.
So theoretically, if you as an operator vote on something, then community later can decide to undo that or cancel that if they don't like that.
Yes.
Okay.
Yes. Yeah. Okay. So going forward, let's see, we just did execute. So this is setting a delay. So it sets a new delay for the time lock. This is setting a new pauser. It can't be address 0. And the set delay just calls this internal function. And same with the set pauser. It's just in a weird order, I guess. Then execute transaction just calls this call data on this address. And I showed you this one before. So this is the sanity check from the constructor. So yeah, any questions on this contract?
I have some questions.
Yes.
I hope by just clarifying a few things with my questions, I won't by mistake find any vulnerabilities that someone else could have found.
Yeah.
But okay, once all the multi-sig addresses are set, can they be changed?
I think the pauser can change, but not the other ones.
Okay, but if the community, for example, can vote for setting a pauser and setting themselves as a pauser, they can potentially change the rest of the addresses, right?
They can't change the addresses of the other they can't change. They could set a pauser, I guess.
Yeah, and that pauser can then change other addresses, right?
I'm not sure about that.
So the only address that can be changed is the pauser, and the rest of the addresses are
Yeah, there's no function to change the other addresses.
Yeah.
Okay, then, please, community, whoever is listening, please check that.
Yeah, yeah, check that.
And remember, write the POC.
Yeah. Cool. Were there any? I'm not looking at the chat. So were there other questions with this one?
For others to know, there was a question about minimum delay and 7 days and time that cannot be paused. These are the two main questions.
The other one was time lock cannot be what?
Paused.
Oh yeah. Okay. Cool.
It's Cheyenne actually. Cheyenne 8, would you actually review just probably the last 10 messages of the chat and just give kind of a explanation of those questions for those who are listening but not reading it?
PufferVault storage. Yeah, we just quickly touched on that earlier. They're getting ready to proof of concept. Great. You can change the delay to 2 days. Let's see. So
yeah, the thing is, we
this
can.
set
You
delay,
want to go to the code?
this set delay function, right here. So this sets a new delay.
There's a minimum 7 days that we cannot go lower than this.
2 days is the minimum.
Oh, is it? Oh, I thought it's 7. I think it's 7.
Seven is what we deployed, but right here, I think it's 2 days.
Oh, okay. Then I sent the wrong answer on the chat. Sorry about that.
Okay. And let's see here. Timelock cannot be paused. Pause any action from other multisigs. So yeah, so I also want to clarify that right, all the multisigs are trusted parties, which we don't expect to do bad stuff. So yeah, I want to say that. And this is good, right? I think we covered everything. Oh,
Yeah.
so much uncertainty. Yeah, I'm trying my best, but I encourage you guys to, if I even say something, right, and it's intended, then hopefully, I mean, if you guys can figure out a way to break it, then that's also good. So, okay. So we're on the last contract then. So this is PufferDepositor. So this is one we're talking about where this basically facilitates doing some swaps and some unwrapping of other assets to put them into Steve for depositing into the vault. But it's in the process of being, all the swap stuff is in the process of being paused. But if you can break that time lock contract and then are able to access some of these other functions, then that's totally fair game. So here we just have, again, like just some internal variables for Steve and wrapped stake Thief. And this is what 1inch and Sushi represent Ether as. And then the addresses of the two routers there. And we have the vault itself. And our constructor just initializes those. And let's see. It is saying this contract is able to give the PufferVault the max amount of Steve. So it's basically just almost unlimited Steve. And so we have Sushi and 1inch as routers that we use to swap assets to. And also, I want to quickly mention that first of all, like there's other audits that touched on using like malicious tokens and stuff like that, and then also like slippage concerns and stuff like that. So we also have a front end which addresses those, but you can read about all that discussion stuff in our 3 audits that we have. But yeah, so basically this takes in a token and the amount of that token and some call data, which is generally like the swap route and stuff like that for the swap. And it grabs the token from the sender onto this contract and allows it to be spent to the 1inch router. And it does the swap with this call data. And it grabs the amount out and then deposits that. So it turns whatever token into Steve and then puts that into the vault. And this one is the same thing, except instead of the user, in this case, the user has to approve their token in to the PufferDepositor vault, or to the PufferDepositor contract, sorry. And this one allows you to use a permit to do a gasless signature to do the same thing. And this swap could be Sushi swap, yeah. So this has the same kind of interface, except here you have the like basically slippage tolerance, so like the minimum amount out, and same thing. So you approve basically that the sender can send their, or sorry, this is assuming that the sender has already approved the ERC20 to be spent by this contract. This takes that token from them and then allows the sushi swap router to be able to spend that amount, and then does the swap with the given route code, and it makes sure we don't get 0, and we deposit the stETH that we receive to the vault. And then again, this one does it without having the user have to approve to spend their ERC20 token to this contract, and then uses the gasless signature and does the same swap. And then this function,
Just clarifying, all that
yeah.
said, those swaps are the ones that are going to be called in a day or two. Just want to make sure we emphasize on that.
Yeah. So yeah. So these are like out of scope unless you can break the time lock pause functionality. So yeah. So this one is wrap staked ETH. So it, like, the way that it works is like it tries this permit. So either you can have previously approved this contract to spend your wrap staked ETH, or you can use a permit, the gasless signature, to permit this contract to spend your funds. So whichever way you choose, it will transfer wrap staked ETH from from you, the user, to this address, and then it will unwrap the wrap staked ETH according to the amount that was in the permit. Or you can also the way that this is called when it's not using a permit is just that this can be empty and unsigned, but it just uses this value still. And then once it's been unwrapped into stETH, it deposits that into the PufferVault and deposit stETH. Basically does the same thing except no unwrapping, so just either permit or you've approved. And it still uses, if this is an unsigned permit, it still uses this amount to figure out how much it should transfer to this contract and then deposit into the PufferVault. And this is just the other authorized upgrade function we saw earlier. So yeah, any questions on this one?
On this one, I don't think so, but there was a question about invariants. If you have invariants for this contracts, if you have written them somewhere, if you can talk about them.
The only invariant that I really said was technically no one should be able to withdraw funds that I mean, no one should really be able to withdraw funds at this point. So we could just say that. I was gonna say you're like your own, the funds that you're due according to the ERC 4626 shares. Yeah. So that's the one that I've written down.
Okay. A question regarding the vault. Is this using that vault token EIP, right?
Yes, but I did mention in the doc that there are things that we don't adhere to. So for example, the max redeem and max withdraw do not follow ERC 4626 specs, because even though the contract or like those functions would be either paused or unallowed, the max withdraw does not take that into account, whereas the spec says that it should take that into account. So I've documented, I've sent it to Immunefi. That's in the doc. It's specified what we do not follow from ERC 4626.
Okay. And another question regarding the vault. How do you protect yourselves against a first depositor bug?
I think that Cheyenne, do you know? I think that the defense on it was that we would be like we have to be like a first depositor. So
The bug basically is like between the deployment and the first like set and depositor. So
yeah.
basically like it's past the point that like that is a feasible attack. We considered that, we looked into like protecting against it, but we're not planning to deploy this again and again. So the time has passed for that bug to be applicable.
I think we also were the first depositor too, as well. But
Yeah, I
yeah,
think
but
for the
it's
test. Yeah, exactly.
yeah.
Okay. For now, who can deploy new vaults? Anyone or only multi-sigs?
Well, anyone can take this contract and deploy new vaults, but we don't plan to deploy new vaults for our purposes. We just plan to upgrade.
Okay,
Yeah.
that clarifies it. Any other questions regarding the code?
There was a
Looking
question
at-
on the chat I didn't necessarily get, was like about cancel transaction, how message sender can be both operations multisig and also the Timelock contract. Just want to look at the cancel transaction to make sure
I saw
we
that
address
too.
that. Yeah, I
Yeah,
wasn't sure.
they're kind of right. I was reading it, and
That basically means that operating signature. That is an interesting message.
yeah, this is a question for our lead developer, frankly, or some smart white hat guy can figure out why it was like this. Let me think about this for a second. I think
I believe this if is just if somebody would be able to make Timelock call something, and the message sender will be Timelock itself.
that's what I was trying to think of, but then it should be
So the second one
Wait.
is for the Timelock being calling this themselves, and the first one is just the operational multisig cannot do that for some reason.
Yeah, isn't it like if we negate this, I was thinking like I think this does make sense. If it's not this and not this. Yeah. So if it's either one of these, it's fine to call it. Right? It's just like the negated version of what you would expect it to be. I think that's why it's looking weird. But it's saying like if you are neither the operations multisig nor this contract, it's unauthorized.
Yeah.
Yeah. Okay. Yeah.
Better to ask lead developer.
Sure. Yeah.
Yeah. And if there's like a potential issue that someone can exploit, prepare a POC.
Yep.
Yeah, when we got a double check on that answer from your lead dev, we'll also drop that in the Discord channel for everyone.
Yeah. Cool.
Okay, then moving on. Looking at all the code that you just shared, in your opinion, from project perspective, what is the most critical and dangerous part of the code, and that is so critical to the whole security of your protocol? Looking at just those 4 contracts.
Yeah, I think the most like dangerous thing would be if there was some way to steal people's funds that are supposed to be safe. So like anyway, firstly like if someone can just like some unauthorized person can withdraw, or if someone can do something that messes with like the accounting of ERC 4626, like how they account for like shares like after you deposit and stuff like that. Any of those things or like really would be like really critical.
Okay, and I know that the next question will be mostly best asked to a lead developer, but maybe you will know the answer. What from the development perspective, which part of the code was the most difficult to write?
Yeah, that would be a
Yeah,
question for the lead developer. I think
yeah.
I asked him a couple things. Let's just see if he has anything here.
I remember some of the parts were about like Lido integration and also like some of the eigenlayer withdrawal. The eigenlayer one is the challenge still because like a lot of them are still in progress in development. Lido was like the whole part of like the double, like the the stage and how to manage between the stages. Like I remember one of the bugs that one of the auditors found was like if someone directly through Lido requests a withdrawal and then through our
Ah,
protocol tries to withdraw, there's like this discrepancy there, which we solved by like the fix. But there's like some of these issues with the Lido and the race conditions that we can do with withdrawal and deposit. Would be interesting to see. And I know it was a bit of a challenge at first.
yeah. Yeah. I remembered. You reminded me. I did want to touch on that. I can show what that bug was. Real quick, I suppose. Yeah, I saw that, and I also saw the stuff that our lead developer said was, he says the biggest challenge was figuring out the design. This is all stuff that's kind of out of scope. Figuring out the design and how we switch from prenet to mainnet version of the contracts. And
Yeah.
yeah, and then yeah, pretty much that. And then he says doing it ASAP. Yeah, we rushed this out too to get this ready for eigenlayer deposits opening up.
Okay.
So he says the time was a challenge too. But here, yeah, let me come over here and let me show that that one like bug that we had. I'm trying to figure out how to navigate back to this event. Here we go. So, oh wait, let me do this. Oh, I guess we only have a little bit of time, but basically, okay, I'll try to be quick. So basically, what Cheyenne was saying is like, when you guys saw how we had this right here, this minus equals message dot value from this Lido locked ETH. So this Lido locked ETH is supposed to be how much we have queued up for withdrawals. And so what someone could do is queue up their own withdrawal, like it'd be a donation basically to our vault. But what it would do is it would they would queue up their own withdrawal of their own thief to come back to our vault. So then when that was originally redeemed, we didn't do this check on request IDs. So now we keep track of all the request IDs, right? We know which withdrawals have been requested by us and which ones have not been. When we did not have that check, if Alice, right, someone else, does that withdrawal, and then goes and claims it, because our claim is just like public, that would cause this accounting to get messed up, and then we would kind of have a denial of service, because then when we were actually go to claim our own withdrawal, this would underflow, because Alice basically like made it, yeah, I added some extra message dot value that got subtracted off. So that was a pretty interesting one, but you can read about it in the audits as well.
Awesome. Thank you. As we are at the top of the hour, I just wanted to ask last question. I think those are already sent in the Puffer Boost channel, but any educational materials, any audits, past audits, interesting findings, whatever you can send that will help our community find bugs in your code base, please do share that. And yeah, thank you for everything. If there are any other questions from the chat before we wrap up.
Yes, buzzer beater questions, please come in. And to kind of answer Adrian's question about resources, Puffers actually check on their Immunefi Boost page. They have provided lots of great stuff, technical articles, more non-technical overviews, and of course links to the documentation. They also have a ChatGPT agent Unfortunately, I think you do need ChatGPT Plus to use it, but if you do, that is a great way to, answer questions and get up to date on their code. And I mean, if anything, it's even more exciting to look at the new contracts that are coming out. As if I understand correctly, Puffer's going to have a regular bug bounty program for that. And so if you understand this code well, when that scope increases and the complexity increases, you're going to be really ready to hunt on their main program.
Yeah.
Exactly.
That's a great point. Yeah, I mean, if you guys learn about our code, and like I said, like the GitHub is there, and you could look at more like the stuff we have upcoming for future, for bug bounties and stuff like that. I did see this one question: is there any part of our code that is a novel implementation unique to our protocol? So pretty much, if you want to look at stuff that we've overridden from the ERC 4626, that's what I mentioned is like really critical. And if we did anything that that breaks stuff there, that would be. That's like where to look. So anything that we've like overwritten, because a lot of it is like inherited code, but we do override some functionality.
Okay. Thank you everyone for tuning in and listening. Thank you Cheyenne A and Cheyenne B for explaining and walking through the Puffer and Puffer codebase. It was a pleasure hosting you. And happy hunting everyone. Hope that this was useful to you. Please use all the resources. Please use PufferBoost for asking and spamming any questions there. People from Puffer will be there helping you. So good luck and see you on the other side of the bugs dashboard. Take care.
See you, everyone.
Yeah. Thank you guys for coming, and thank you Immunefi for having us.